Section 8.1, right triangles, right triangle trigonometry and applications. What are we learning in this section? As you can see from the title, they talk about right triangles and basically applying trigonometry in right triangles. So right triangle is a triangle with one right angle. So if I draw a right triangle like so, I'm gonna call this angle alpha. Angle alpha. So the side facing the angle is called the opposite. So let's call this A. This is the opposite side. Opposite to angle A, alpha. And let's call this B. That's gonna be the adjacent. And the one facing 90, C, that's the hypotenuse. The hypotenuse. So we define the trigonometric functions using what we call SOHCAHTOA that helps students to memorize this. So the sine of alpha is the opposite over the hypotenuse. So opposite over hypotenuse. So sine alpha, well, let me write it there. Opposite here is A, hypotenuse C. Cosine alpha is the adjacent over the hypotenuse. Adjacent is B, hypotenuse C. And tangent alpha is the opposite over adjacent. So the opposite is A, adjacent is B. Adjacent is B. So what we do in this case, that's how people memorize SOHCAHTOA, S-O-H-C-A-H-T-O-A, SOHCAHTOA. So those are important to know. As an application to this, if I pick a right triangle, call alpha here, so let's make some change. Call this is 513. So what we need to do, didn't give us the length of the third side. You can use the Pythagorean Theorem to find the missing side, which will be 12. And from here I can find sine alpha, which is the opposite, 5 over the hypotenuse. Cosine alpha, adjacent, which is 12 over the hypotenuse. And tangent alpha, opposite over adjacent. And that helps. Why does that help? Maybe sometimes you are given one side only and an angle. Maybe we need to find the other side, like a missing side. Or maybe it's just as an additional tool for us here to learn the SOHCAHTOA. And we will see that in other applications later on in this section. So now let's look at what about if we are given a triangle, right triangle, call this, let's say this is 20 degrees, therefore this is 70 degrees. Call this ABC. So if I want to find sine 20 degrees, sine 20 degrees, by SOHCAHTOA is the opposite over the hypotenuse. And I'm going to find cosine, not 20, but cosine 70 degrees, the other angle, is the adjacent, which is B. Okay, to 70, B is the adjacent, and the hypotenuse is the same, is always the side facing 90. So notice, based on this, we found out that sine 20 is exactly the same. These two things are the same. Is cosine 70. And what I'm going to do with cosine 70, I'm going to write it as cosine 90 minus 20. 90, we're familiar with 90-degree angles. It's cosine 90 minus 20. Right? So what does that tell us? That tells us that these angles here, the 20 and 70, those angles here, those are complementary angles, right? They add up to 90. So those are complementary angles. Those are complementary angles. And in this case, we can call the sine and this cosine, we call them cofunctions. So in other words, in general, we can write that sine any acute angle alpha is cosine 90 minus alpha. 90 minus alpha. Or if you like to write in radians, instead of 90 you write pi over 2, which pi over 2 is the same as 90 degrees. So these are called cofunctions. How can we apply that? Let's say they ask us to simplify or evaluate or find the value. So find the value of, let's say, sine square pi over 8 with no calculator plus sine square 3 pi over 8. Okay, so what do we do with this? Well, let's keep this the same as is for now. What I'm gonna do with this, the sine square, I'm gonna write it as cosine square of pi over 2 minus 3 pi over 8. Okay, and so notice what I did. I changed the sine to cosine, and the square doesn't really matter because sine square alpha in general is sine alpha all square. So it's kind of like you change the sine alpha and replace it with cosine pi over 2 minus alpha, so the squaring will stay there. So this stays as is, plus cosine square. This is multiplied by 4 and by 4. So you get 8. 4 pi minus 3 pi is pi. And now what I got here, with no calculator, I know that sine square an angle plus cosine square the same angle is always 1. So this is an interesting combination of the cofunctions and the SOHCAHTOA, how we use SOHCAHTOA, or the definitions of these sine, cosine, tan, cotan, to get to prove the cofunctions, and then we use cofunctions here to evaluate expressions like this one. More applications. Let's say we are given a right triangle like this, 90, call this 20 again. This is A, B, 4, and let's call this C. Solve the triangle to the right. So what does that mean, solve the triangle to the right? Solve means find all the missing sides and angles. Well, I can find angle C right away. If this is 90, then C is going to be, the other two angles are 90, 20 and C. So 20 plus C is 90, so C is 70 degrees. So we got that small angle C is 70 degrees. How am I going to find A and B? Well, I can't use the Pythagorean theorem because I have two missing sides here. We get two missing sides. So what I'm going to do is use SOHCAHTOA. If I take sine, let's say, sine any angle of them. So if you take sine C, this is 70. Sine would be the opposite over the hypotenuse. Oh, we have both A and B are missing, so I can't use this sine. What about cosine 70? So cosine 70 degrees is the adjacent over the hypotenuse. So notice from here, this is over 1, cross multiply. B cosine 70 degrees equals 4. Then divide both sides by cosine 70 degrees. And what does that give us? So 4 divided by cosine 70. If you do that on the calculator, make sure the mode is degrees. Okay, so B will give us about 11.6 or 70. Okay, that's B. Now I found B. I still need to find A. We can use now Pythagorean theorem, or I can use trig. Since I use cosine 70, I can use sine 70 now. Sine is the opposite over the hypotenuse. Or let me use tangent. Tangent 70. Tangent is the opposite over adjacent. Because I already know the 4, like that side, the adjacent is 4. So cross multiply this times this, so A equals 4 tangent 70 degrees. And we can put that again as we did for the other problem, or the other part, is to give me A about 10.99. So that's an application to SOHCAHTOA again. What are other applications? So let's call it application. There are two things here to learn. The first one is, let's say someone is standing here at a certain distance from some maybe building or something, a tower, and then that person looked up. Let's say it's like that. That's the top of the tower. They look this way up. So they look this way up. This angle here is called angle of elevation. Angle of elevation. And it could be, let's say someone is standing here on the top of this thing, and then let's say that person is that high, and the person is trying to look downstairs this way. Okay, so the person is looking this way. The arrow indicates that person is looking down. And what happens is, if you draw a horizontal line like this, this angle here is called angle of depression. Angle of depression. So the questions about angle of elevation, angle of depression can be in a word problem format most of the time. This is something like you have someone is standing, let's say someone is standing 200 feet away from a building, like a large building or tower. So this is the building, okay, and that person's 200 feet away. And the angle of elevation when the person looks on the top of the building is 66 degrees, let's say. That they tell you in the problem, angle of elevation 66 degrees. This means you need to sketch the diagram to figure out what's going on with this to help us solve the problem. And this is really high tower. So the question is, what's the height of this tower? So that's an interesting problem. You are 200 feet away from a tower, and we looked up to the top of the tower. You found out that the angle of elevation is 66 degrees. The question is, what's the height of the tower? So let's see, what are we trying to do? We are given angle 66 degrees, as you can see it. This is given. What is given here? Adjacent, and I'm trying to find the opposite. Which one works? Sine opposite over the hypotenuse? No. Cosine adjacent over the hypotenuse? No. What about tangent? Yes, tangent. We can try tangent 66. It's the opposite over adjacent. So now this is over 1, cross multiply. H equals 200 times tangent 66 degrees. So what's this? We can put that on the calculator. Again, make sure that the mode is degrees, and that will give us H about 449.21 feet. Okay, so first, don't forget the degree mode in all kinds of calculator. If it's scientific, if it's a standard calculator, if it's a graphing calculator, make sure it's in degrees. The second thing is, always try to round to do 2 decimal places. So round up to 2 decimal places. And the third thing here is the unit. Don't forget the unit. Where did I get the feet from? Well, because that thing is given as a feet. So if those meters, you put meters, centimeters, you put centimeters. Make sure they all match. So this is an application to the angle of elevation, angle of depression. So it could work the same way. If they give you a question about angle of depression, it would be solved the same way. You just have, all you have to do, make sure, is to follow the instructions. So they might say someone is standing somewhere, and then that person looked down. You just draw an angle like this, and then always draw a horizontal line. And then they say the angle of depression, I don't know, let's say it's 46 degrees. 46 degrees. So let's say that person is 50 feet away from this point. Okay, and then they ask you to find, let's say they want us to find this, call it H. So how do we start with this one? Notice how the angle is, it's it's outside the triangle. So I need to work with the triangle using SOHCAHTOA. One thing good to know back from geometry, if something comes like in a Z shape or backwards Z or upside down Z, this angle here is always congruent to this. That's called alternate interior angles. Alternate interior angles. These angles are always the same. So in this case, we have this angle here, and this are the same. So this is 46 degrees. That's one way to solve it. If you forget about the 46 degrees, notice this is always 90. So you can find this angle first and use it, or find that angle and then from there get the 46. So now, again, opposite and adjacent. So now we can do tan or tangent 46 degrees equals opposite over adjacent. Cross multiply, that would be 50 times tangent 46 degrees. Okay, so then H is about, so if you put that in the calculator, 50 times tangent 46, that is about 51.78. Again, feet. Don't forget the unit. So that's those are applications. So to right triangles and trig at the same time, right triangles and trig, and we introduce two things: angle of elevation, angle of depression, and that's how the question is always being asked.